Hey, what's up, Ziguanas? This is a special edition of the 30 Days of Zig Coding Challenge, 10 Days of Zig later. In this stream, I will share my thoughts about my learning Zig journey so far, so the last 10 days. And I will also do a simple tic-tac-toe game in Zig, of course. My name is Dusan, welcome to Zignited. Before I start with Zig, one quick note: I will do a regular stream in a few hours. As soon as I finish this one and just like have some rest, I will do the regular, so day 11 of the coding challenge. But now let's go to the summary of, not summary, I will not do a summary. I will just quickly share my thoughts on my journey so far, what I think about Zig, and I will go straight to coding. So yes, still I don't know many things about Zig, so I just went through the basics, like the literal values, the variables, the constants, the pointers, arrays, slices, loops, so while loop, for loop, conditions, and that's pretty much it. So I haven't touched functions, I haven't touched enums and unions, structs either, so I don't know anything about them. I did go through the operators, and that's pretty much it. So today I will use just the things that I know so far, that I've learned so far, and I will not use any other things. And speaking about this learning part, so I was trying in these first 10 days not to do anything offline. So this was kind of like the point of this documenting process. So I wanted to document everything that I do online in live streams, and I didn't want to do anything, let's say, offline. But simply I've reached this point that the things are getting increasingly more complicated, and I will have to recap the things that I've learned. So this is something that I haven't mentioned before. I did speak about what I think is the best process and structure, how to organize learning from my experience as a co-teacher and as a developer. And I mentioned that practice is the most important factor. So that's why I try to hack things. So even though I don't know, so I just like read something in the docs, and then I try to hack and try to change things, break things, and so on to see how it works. So this is important. That's why I'm also going today to practice what I've learned so far by creating a simple tic-tac-toe game. But also the other aspect that is important is refreshing your memory and like pushing that short-term memory things that you've learned into the long-term memory. So that's the process that is also important. And that basically means going through the things that I've learned, like repeating things. And I was just like having this dilemma: should I do it online? Because it will probably be boring if I just like stream myself rereading the same things. So that's why probably I'm not going to do it in live stream. Maybe I will record myself and then I will just like edit. I will cut the pieces and I will just like condensate this into a shorter video, so that maybe I have also this documented, or I will completely do this like off cameras. But from now on, for sure, I have to do this recap thing because the things are getting more and more complicated, and I cannot just like go forward without revisiting the things that I've learned so far, because I will forget them and I haven't learned them by heart yet. So that's the reason. Okay, that being said, what I like so far about Zig, like maybe some details that I love, is, for example, that it doesn't allow you to create a variable and not use it, which basically means that if you don't want to change, not change it, sorry, which basically means that if you don't need to change a variable, it shouldn't be a variable, it should be a constant, which makes it a compile time known. And then it will increase the performance and the stability. I also like that the constants have to be used again. So even if you have a constant, you cannot just like create one and not use it in the code. The compiler will not let you do that. So again, you will get rid of the things that you actually don't need from your code. So this makes a difference when the code base is bigger later. So of course, in this simple example, it doesn't matter that much, but in general it does. So this is about variables and constants. It's interesting that it doesn't have a string type, that it has just a literal, because it's a low-level language compared to Python and some others. So this is interesting thing that I like as well. I also like how it works with slices, so that it tries to optimize if you have a compile time knowledge of some, for example, the ending part of the slice, it will then actually run as the pointer to an array, basically under the hood, from my understanding so far. So these kind of optimizations I like, that it will try to make an array which is compile time known type, right? So it's going to do that as much as possible. That's the part I also like. Then the operators I've seen, so I didn't use some of these safeguarding operators that don't allow you to go outside of the type's size. So I've just seen them, so I haven't used them yet, but I like the idea of them, which make the operation safer and more predictable. So it will not allow you to go outside of the size. What else I like that I can remember from the back of my head is, I also like, yeah, with the while loop, I like this version of it when you actually do this. So when you kind of pull out the variable that you want to use as a control variable for the loop, and that you can kind of like extract it outside and do this outside of the code block, but it still runs after, so at the end of the loop. So it's kind of like a design that I like. That's what I like with the while loops. With for loops, I haven't played with them a lot because I didn't understand this at the beginning. Later, I kind of got the basic idea, but I didn't use them. So I think, use the most simplest version of it. I don't actually remember how deep I went, but I definitely have to play with for loops more. With conditions, pretty much everything straightforward. Again, I didn't use these, how they were called. They were like called, not patterns, but I forgot the name for it. But yeah, so this is something that I haven't used yet. I've just touched it, so I cannot speak about those things. And that's, I think, about it. So I don't have any more thoughts on these things because I haven't used a lot of these other things. And yeah, I like the formatter. So I like that you can use, for example, what I did yesterday, that you can use, for example, a slice, and then if you format it with a star, it will give you the memory address and the type. And if you use any in the formatter, it will show you the elements. So I didn't notice this before. So I was using both, but I didn't pay attention like what is actually displaying. Now I've seen and understood that yesterday. So this is what I like. Okay, so we can now start with tic-tac-toe game. So because I didn't do any user input here, and I don't even know if it will work here in this online runtime that I use for now. So one more reason why I will not try to do this. And I don't want to learn anything new now, like cover new topics. I will just use what I went through. So because I cannot have a user input, I will just create some, let's say, predictable game of TikTok. I will maybe create an array of moves, of choices, like first, let's say the player 1 goes to the first field, the player 2 then goes to the last one, or something like that. So I'll do it in that way. And I will not use functions, which I would like to use here because I want to check things. For example, if there is a sequence of 3 X's or 3 O's in a line or in a diagonal or column. So it would be easier to use functions, but I haven't touched them yet, so I will not use anything that I haven't touched. So let's start here by creating a variable. And I will make this one. So let me think. I want an array in which I will store the graphical representation. So basically a string that will be an array, because under the hood there are arrays, where I will basically have X and O. So I'm thinking about something, and I will copy paste a lot because I still haven't remembered the syntax completely. So I don't want to spend time on that. This is what I will do in that second part, where I will go offline through the things that I've done so far. Okay, so I need strings or arrays just to see. Let's do this one. And it can be actually as a constant. I will not change. So let's do a constant, and let's say something like symbols. I will call them symbols. And I need X and I need O. That's pretty much everything I need. They can be UI, that's fine. The size, I can fix it to 2. I will not change the size at all. So these I will use to print the board. And I can also, so I will kind of like do an offset probably. I'll do a modulus for the odd turns. I will use, so turn, because it can be maximum 9 turns, right, in Tic-Tac-Toe. So for turns 1, 3, 5, 7, and 9, the player is X, so 0 is the index. So I will use that then as an offset. That's the idea. And when there are even turns, I will use the offset 1 for the second player. So basically, I know I will need some while loop here that will be running 9 times, maximum 9 times. And I will use this version of the while that I liked. So this one. Yes, I can be. So let's call it turn. And let's say it starts with 1. And let's say while I is lesser than 10, that's okay, because when it's 9, it will be the last turn. I want to increase I and just sanity check. I will print this here, the turns. So let's say turn. And here we want I don't need this. Let's see what I did wrong. I call it turn, yeah. So mistake. I forgot I changed. Symbols. Okay, I will comment out, yeah, because I don't use this yet. Just for now, I'll comment it out. Yeah, turn 1, 2, 3, 4, up to 9. Perfect. So now let's actually use this. Turn 1. It is the move of the player, and let's interpolate here. One more thing. And from here, I want symbols. Right, that's the name of my array. And the index should be 0 for the odd numbers. and 1 for the even ones. So if I do the turn modulus 2, so this will give me in the first turn, when it's 1, this will be 1, right? So in that case, I need actually 0. So I can switch them, it's easier, so that I don't do any math transformation. And this should be pretty much it, what I need. So let's test this. Oops, what did I do? Why 8879? Aha, this, yeah, because it's a string. Okay. So this is the actual string inside. I cannot just take it out. I have to format it as a string. So let's try this. If this will work. No. So I have to cast it then. So, but there is no string as a type. I forgot if there is a character type. Let me see here. So let's do the beginning. Let's say character. Okay, C char. I don't want to do those. Yeah, this is where we displayed the strings. So basically here they do it under quotes, but this is not something that I can do if I want to extract it from an array. Let's see some other examples. So here they got the E from hello, what is it? Yes, from here. Okay, so this is under the hood, a little bit different type. So let's do it in that way. So instead of doing this, I will just say exo seems to be the easiest fix. Now still I get the same. Why? Wait, here I take the index and I get E. Aha, C. Okay, this is what the part that I was missing. So probably then it will work with the previous. So let me try with the previous because I'm curious and I want to learn. So here, if we say C, and this is why I need to recap because I forgot these details. Yeah, now it works. So move the player X, move the player O, and then it will be the same if I do it in the second way that I just want to try. Yeah, so let's leave this one because it looks simple. I still don't know if under the hood there is some difference in performance, but if I use the literal, I mean during the compile time, but it's so irrelevant for this example, just like thinking out loud. Okay, so now I have the turn number, it's correct, and I have the player character, and I would actually want to save this in some kind of variable, probably, if I don't want to repeat all this turn %2 every time, because I would probably want to inject it later. So if I actually wanted to do this, let's see if I can just say, for example, variable equals, and then let's say this part there. And if I can then just use this, of course, variable will be, let's say, player. So let's say current player. Let's call it current player. And let's try to do that here. And again, First of all, I don't know if this is going to work for multiple reasons. One of them being this is recreated here, redeclared in a while loop. And because it's variable, maybe because it's not changed here, it will break for that reason or a million other reasons. Hello, Andrew. No, I haven't installed Ziggling. So for now, I'm just working online. So I will do that probably maybe tomorrow. Today I will not make it because I don't have time after this stream. I will stream a normal one, the 11th day. So maybe tomorrow. Let me see what the error is. Never mutated. So let's try and use this actually here. And if in this case it's not known, this variable, I mean, I can still use it here. Let's leave it, it doesn't matter. And I just want to keep that here as well without the var part. Just see if this will run. It seems to be running fine. Okay. Perfect. And what will be the type of this? Because I just format this as a character. What will be the type? So probably U8 slice of array or something. I don't know. Let's see if I print the type of this. So I can do it even here. Same thing. So let's say parent player type is, and then let's do this. And let's do type of parent player. Yeah, U8. Okay. Single U8. Okay. Yeah. Makes sense. So I will just write this as a note to myself here. So like this, that I forget U8. Okay. So I don't need this anymore. This is fine. And let's see what I can do next. So I have to have this because, like I said, I'm not going to use user input. So I have to have something like the sequence of moves that I will read from. So an array, for example. And then I will use those to populate another array. I need another array where I will actually store which character is where on the board. And of course, I have to print the board. So I have to have something like a board, tic-tac-toe board, first of all, so that I print it. So let me create an array for that. So let me try to do it from my memory. So here I will create, it can be a constant because I also want to test if constant is for the actual array reference, not the content. I want to call it board, and it's going to be, let's say, size 9 of, was it like this, U8s, and then here I can do this. And I can repeat. So I believe, I forgot how I multiply. I remember there is multiplication, I think square brackets and then 2 stars to multiply, but I will do this time manually just to not lose a lot of time on these things. So I will just repeat manually this. So this is 3, 4, 5, 6, 7, 8, 9. And let's just print this because I want to see if this will run. Board. equals or is doesn't matter. And let's just do the board here. And I believe I have to use any here. And let's run the code. Yeah, of course, this is now formatted as a number, but it's okay. This should be the number of this character, okay. I mean, this is hexadecimal, not decimal, so it's not 95, it's 95 hexadecimal. So I believe it's going to be fine. Let's go now and print again, just for the sanity check. Here I can actually do the same thing. And I can say board, square brackets, let's say 0. And this time I want to see the character. I want to format it as a character. Yeah, it's okay. So this gives me underscore. That's what I want. Then what I can do at the beginning of the turn, I want to print the board, but like 3 pieces of it in a row. So let's do one more while here. And this time I need another variable, which I can, let me see if I can declare it here. I'm still not confident with these scopes in Zig, and if this is going to work if I redefine it here, or I have to define it before outside of this loop. Let's try. So this one, let it be I, and let I be lesser than 9. Okay, so actually let's start. Let's do the index, not the human number like for the turn, but the index. So lesser than 9 then. And I could go also with the size of this, but I will fix it to be 9 because it will never be larger than 9 in Tic-Tac-Toe. And then we have I plus equal 1 here. And for now, just let's see if I can print. Let's print I for now. So I'll just print I. Equals, and then let's do I here. And I will leave it as print, not print line. I mean, I will not do \n, just because I would like to see the numbers in one row. And then for every turn, I want to see all the 9 numbers, if this is going to work. Okay, let's run the code. Why? Ah, I said it, I left it. Okay, let's do like this. Not n. Okay, doesn't matter, it can be n between the numbers. Yes, so this is fine. I actually just wanted to do this without all these other things. Hello, Robert. Nice to have you here. Yeah, I've made like 10 videos so far. So you can go through those first and then come back to this one. Let me see what I got here. Yeah, so this is, yeah, and because I don't print at the end, so let's do just one empty print at the end after here, so that I have at least \n, so that I go to the next line, and this time I believe, oops, I have repeated this, so this is, I believe, the empty struct, which is enough if I don't have these curly braces here to make just like this part print. And yeah, it will break. No, sorry, I'm looking at the wrong one. So this one I was watching. Yeah, so should be the enter. Yeah, it's okay. It's okay. This is cool. Okay, now let's break this so that I print, for starters, 3 numbers per row. So basically what I want to do here, I want to repeat this not only once, I want to do this every time when my index is 2, 5, or 8, right? So this is what I want to do. So let's see. I can do it by turn. I can do the modulus of turn, right? And then it will be, yeah, I can just do the modulus turn. I don't have to consider these i's. I can just do the modulus turn. That's probably the easiest solution. So let's do here the if condition. So if, and then let's say turn modulus, where I had it here. Too lazy to type things. So if I have turn modulus 3, that should be 0, 1, 2. So if this is equal to 2, so then I want to print this. Let's see if this is going to do what I think it will, or I made a logical error. It just runs. What does it do now? It's weird. Yes, sorry, my mistake. So yeah, I have to consider the I. So I cannot. Let me see what you asked, Robert. Just asking, have you seen? Or yeah, I've did for loops, but I just touched them because of this expression. I forgot how it's called. It's not pattern match, something like that. There is a name for it. It starts with C. I forgot. So it looked confusing to me. So I've never seen something like that before. And then I did the research, and then finally I understood it, but I didn't go back to for and using them. So I will have to do for loops in the future. Zatos, how about you show us your cool projects? Yeah, I would love that. So I'm just starting to learn Zig. So I literally haven't done any Zig coding 11 days ago. I haven't touched Zig. I didn't do a single line of Zig code. So this is like so far what I've done so far. I've learned those things that I apply here. So literally like Tic-Tac-Toe game is something like what I can do now. I cannot do any more difficult things. Yeah, capture group. Yeah, that's it. Thank you, Robert. Capture group. That's it. Okay, yes, of course, I have to consider here not the turn, but the I. So let's say if I, and because it's index space, so it will be 0, 1. So I believe I have to say I plus 1. Let's see. No, still doesn't work. Why? So if I plus 1, 3, so we have I that is 0, 1, 2, 3. So in this case, when it's 2, I plus 1 should be 3, and then the modulus, okay, this is 0. Yeah, first of all, it's not 2, it shouldn't be 2, it should be 0. But anyways, it will, I'm missing something still. Maybe the priority of the operator, so I will have to try putting this into the parentheses. Let's try that. If not, I'll just print what I get so that I understand at least what I'm having. Yeah, let's print, not to waste time. So let me do here another print. Well, I will just inspect what's happening. So let me print this part here. So I have I, and then I'll have the I plus 1 modulus 3. And then I can even comment out this part here for now. And then in every line, actually, I can do this unconditionally for now, just to see what I have here. And let's do a space after that I see visually better what's happening. Okay, so 0, 1, 1, 2, 2, 0. Yeah, so it is, oh no, it's not. Give me a second. So let's just do here like 3 dots or something that I see them better. What is happening here? Okay, 0 and 1. So when I is 0, I have I plus 1 modulus 3, 1. So that makes sense. Then when I is 1, this is 2 because 1 plus 1 is 2. And then if we do the modulus 3, it's 2. That makes sense. Then here when I is 2, this is 0. So why then this doesn't equal 0 here? What am I missing? Let's do another print. Yeah, it looks okay, but for some reason it doesn't catch. Ah, my mistake. I'm doing it outside the loop because I'm thinking a different thing. And then, okay. So of course here, it should be here. And then let's comment out these things. And I don't need this one anymore. Let's see. And I don't print. Yeah, I commented out the print of this. I, of course, want to print I. I don't want to print nothing. When I was learning Zig a while back, I used to do Zig links exercises also. Nowadays, there is a decent LSP if you would be interested in trying. Oh yeah, that's a good idea. Oh, I thought Ziglinks is like the, how it's called, like the linter for Visual Studio Code. Aha, so Ziglinks is something different, like the exercises. Something like lit code for Zig, right? Yeah, I will definitely check it out. Okay, finally I have what I wanted from the beginning. So this, let's say, 2D representation of the board. Okay. So this part looks fine now. And I can basically use the same logic to display what is in the board. So I can just loop through this one and do the same thing. So instead of this, I can kind of leave it as a hint where is each of these fields, but I don't need to. I will remember they are the indices, so I will just comment this part. If I need it, I will easily turn it on. And now instead of printing this part here, I want to actually print the character that is inside of this board, how I call it, board, on that index, which are all going to be underscores at the beginning, but just to actually have that. Yeah, and they look ugly, so I will probably do a space here so that I separate them a bit. It's easier to see which one is which. Okay, so this is okay. These are like rustlings, a bunch of small exercises. Okay, you have to install Zig on PC. Use Tic-Tac-Toe version 0.14. Thanks, I will try that definitely. I was already thinking about installing it, so I didn't want to install right away so that I spend time installing things and doing it online. I just wanted to jump straight in into coding, but I will definitely, because now it's becoming more and more complex to work with. So I would definitely like to have ID help Okay, so the next thing would be that I actually implement these moves. So I will create, I can literally call it moves. And I can make them U8s, and I will just randomly move things. So let's do, let's say first 0, then let's say O place 9, then 2, then 8, then 3, 7, 4, 6, and 5. And I will not check for the winner, nothing, just like to see if it's going to populate these boards and if I will see the change. So I need to do that before I print it for the first time. In this case, of course, in the real game, you would actually print this first, the empty board, and then ask the player where the player wants to move. It is small programs that you are fixing that have great comments in them. Aha, you get to know a lot why something is the way it is. Okay, that's cool. It's targeted on people that know how to program but are new. Okay, perfect, perfect. Thank you a lot. I will definitely try it. So here, before I print the board, I would actually like to populate the board with a specific sign on that specific index. So basically, I want to say something like board, square brackets, and then I take the moves, square brackets, and then the turn -1, right? Because I have human numbers for a turn, so it's not index, and it should be adjusted by 1. So this should be equal to what is actually depending on this, right? So what is the, how I call it, current player. So this should be a current player. So let's see if this will work. I forgot if I can just change the array like this. No, cannot assign to constant. Aha, so definitely this cannot be constant. So let's make it var variable. I thought I've seen like that when I had a constant array that, I mean, const here, that I could change. Maybe I'm wrong. It looks like I'm wrong. So I was thinking maybe like the pointer cannot change the address of an array or something, but obviously not. So I was okay. So yeah, it looks okay. Then later it breaks. Let's see why. What happens? So in the first one, it looks like okay. Then panic index out of bounds. Aha, so I've messed up the index somewhere. Let's see where, zig 25, 25 here. So let's see why. Turn -1, so the turn is 1, then 2, right? So when it's 1, it's okay. Then here, when it's 2, this should be 2 minus 1, 1. So then moves 1, why it's out of bounds. It is there. What am I missing here? Turn 2 is the move. Why is this out of bounds? Turn. And I literally print it out here, right? So turn, here is the number of the turn. And I use it here. So how come 2 minus 1, which is 1, is out of bounds? It's like when I change it here that something happens. So when I do this, so let's say in the first, this is 1. So 1 minus 1 is 0. So move 0 will take this value. which is 0. So basically this will be 0. That's why it's on this location. It looks fine. But after that, something happens. Let me print the board here just to see how it looks like. I'm just curious why. Why this breaks. Okay. Yeah, this looks nice. So it does contain 9 elements. Let's print it one more time at the beginning, actually. So let's see, after saying what is the turn, that I print the board here. Yeah, it looks completely fine. Turn 1, the turn 2, it is still fine. Length 5. Aha, length 9. Why it's length 9? Oh, my mistake. Okay. Yeah, human numbers. I wanted to say 8 is the last index, so I have to decrease. So this is 0, 8. Then this is 1. So I started only the first number that I used. I used actually the index, but then I switched in my mind to human numbers. So 0, 8, then 1, 7, then 2, 6, then 3, 5, and then 4. Okay, now makes sense. So this board I don't need anymore to print. And let's run the code now. Okay, now it does what I wanted it to do. So it's dynamically changing the characters, but I still don't check, of course, anything like the winner state, the winning state, or if the move is legal. So of course, in the real game, I shouldn't be able to replace. So if I change here, for example, let's do it here at the beginning. So this would basically replace the first X with the no, and that shouldn't be allowed. So I still have to check what is there. So then, yes, I have this inconsistent, illegal state of the board because of these things. So this shouldn't happen. I should check, of course. Okay, so let's see what would be the next thing. So I have the sequence of moves. Now I have to do these checks. So if it's the legal move or not. So first of all, the field has to be empty. So before I do this, I should be able to say something like, if the field is empty, then you can do this. Otherwise, now because I have just like one loop here, I don't have any, and because this is static, so I cannot change this dynamically at this moment. This I cannot do anything with it, but I can just at least stop something, or I at least say this is wrong, and then move to the next move, let's say. But at least that I can implement something like this, like a check. So let's say if, and let's say I will, because I don't want to repeat this thing, I can make a variable, but let's repeat it, doesn't matter actually. So I just want to speed things up. So if this thing, right, is not equal to 80, what was it at the beginning? What was the number of the board? Empty 95. So actually 95. Yeah, this is hex. It's not 95. Let's see if I can just ask if it's equal to the character literal. Yeah, let's try that. I've never tried that. So let's see if this will work. So only if this is the case, I want to populate that field. Let's see if this is going to run. So far, yeah, I have everything valid. So if this is not a mistake, if I can compare with the character. This should be fine. Yeah. But it doesn't, it doesn't recognize, so it doesn't think this is equal. So it doesn't recognize it as the character literal for some reason. Let's try to see if I can do 0x95. Is this allowed? No, still doesn't recognize it. So wait, do I have the correct assumption that at the beginning it's yes, it's 95? I don't think it's decimal. Sorry, my mistake. I didn't copy the entire thing. Okay. I don't think sometimes. Okay, this is passing, but I still want to check just if this is... so it's definitely a decimal number, not hexadecimal. Yeah, it's decimal. Okay, so let's just test if this is also going to work. Yeah, it looks like it will. Yeah, nice, nice. Now let's just test this situation if I don't have the right sequence that I want to try. The right choice, let's say. Yeah, so in the turn 2, it just keeps, it doesn't do anything. Of course, this is now like completely off because you have more turns played by X. But like I said, I cannot do much about it without user input, so that I can add these additional moves here and then play in that way, yes. And then actually if I do that, and also in the, let's say, the final version, if I include some interaction with the user, then definitely here this would be in a loop. So as long as you don't have a valid move, you loop through here. So I will have to do some kind of flag or while true and then break it, something like that, and then do the test for that. Okay, so I can do that now. I can play, so I will just increase the number of moves. So I don't touch this one. This one should stay 9. But the number of moves, I can say that it's dynamic. So let's say let's see first if this is going to work. I think it will, just to see. Yeah, it's fine. It looks fine. Okay, now let's try here the correct one after the wrong one. Oops, did not want to do that. And now let's create the while loop here. So let's say while true. Then, yeah, I forgot I will have to, because now I have the turn, but I actually have to increase the turn. And the turn is fixed to 9 right here, yes. So this then cannot be 9. This cannot be 10, because theoretically someone can try like infinite number of times to do so, but I can use some large number, and then eventually I can break it once I reach. So I can actually create a counter how many fields are filled in, right? Yes, this is also something that I can do instead, so I can still keep this part, because theoretically it cannot. Maybe this is more correct, because theoretically it's not a new turn if you try to play where you shouldn't. So it's still the same turn, but it's invalid move. So basically I can create a counter for how many times I have populated the board. So let's do that. Let's say here it's a variable, so it's going to be, let's say, moved I'm out of ideas for the better name. So let's say, yeah, I can say moved or played. Let's say played, doesn't matter, played times out of idea really. So let's start with 0. Then here, if we do this, if we detect it's a valid move, we increase this by 1. So played times, or let's call it legal moves. Let's say legal moves, maybe it's better. Legal moves number. I mean, it's a number, I don't have to say. It's a number, legal moves. And then here I can do legal moves plus equals 1. Only under this condition. And I can also break the loop here under these conditions. And here now I have to switch. I'm not using turns. I have to use something else. So I have to do a variable here that will at the beginning be turn minus 1. And then, I mean, this is one of the ideas. And then I increase it by 1. But yeah, this will mess up things here. So they are related. So I cannot touch a turn. Yeah, I can use actually legal. Yeah, that's why I made it so. So I can ask if the legal moves is equal to turn. That's the best solution, I think. The one that I can think of now. Okay, so then I basically, or actually, do I need to? Yeah, I have to increase it here. So at this time at the beginning, the legal moves is lesser than the turn number. So that can be actually my condition here. So I can say while move, how I call it, legal moves, lesser than, yeah, but I have to increase. I'm keep running in circles, so and this is not my problem. The legal moves. The problem is that I want to count these illegal moves, let's say, so that I can move forward to another move. So I can call those just like a move. And I can equal this one, actually, not the legal moves, so I don't care about this. Yeah, basically what I call legal, it shouldn't be legal. It should be just like potential move, maybe. Something like that. So I confuse myself with the name. So let's say potential move equals 0. So then I don't do this only under this condition, and it's a different variable now. I want to do it here immediately. Is this the way you spell potential? I think it's with T. Yeah, it's with T. Okay, that was an error. Potential move. So potential move equals plus equals 1. And then, actually, this has to be after the condition, right? Because I want to try first. If it's 0, I want to take that one as well. Okay, so here I increase it by 1. And then here I don't need to count the turns anymore because I have this variable now where I will basically increase the potential move every time. Yeah, this is so complicated because simply I don't have interaction with the user. It would be much easier than counting and thinking about potential moves. But anyways, this is how we learn, right? So if the potential move, the index of that board on the board is empty, then let's populate. Otherwise, I increase anyway. So no matter if it's, give me just a second. No, this I'm inside of the if, so I want to do this outside. So where is the while? Ah, I started and then I didn't finish, so that's why I got confused. So this is the while, right? Yes. This is the if, stopping here. So this has to be unconditional. That's what I wanted. And I don't need to break like that. I can say while true here, and I can actually break here. If I go inside, this is cool, but I have to also increase the potential move there as well. Of course, before the break. Okay. Let's see if this makes sense. And so what I expect to see, I expect just to skip this turn here, not the turn, but the move, and still stay in the move 2, and then place the correct one. Let's see. What is it? What did it do? Variable type com time int must be const or com time. What did I do? Unused local constant. Most didn't I? Aha. Yeah, I completely forgot that I. Oh, come on. So this is, of course, from the moves. Yeah, I just wanted to delete the turn, but I deleted the entire thing. This is, of course, what I had in mind. So this should fix the first error, but let's see what was the second one. How come I don't use it here? Why is this comp time int? Potential move equals 0. I do change it here. Why thinks that this is... Why is this different than, for example, the turn here? Okay, use size. So I haven't specified the type. Runtime number int size. Yeah. So I forgot to specify the type. That's why. So this one, thank you, Robert. This is what I've been missing. Yeah, it looks like it's running now. Yeah, okay, perfect. So I think I fixed this problem. So now theoretically I should be able to have infinite number of invalid moves. And this mechanism here should take care of it. So that I still have only 9 turns. Yeah, okay. So this is for the moves. Now the only part that is missing is to test for the winner. And then stop the game if there is a winner. And that has to happen after the change of the board. So after this part here. So I can still print the board. That's fine. But then here I want to test if there is a... If there is 3 in line in any of these combinations. So let's do a simple thing here. Let's try to do, let's say, if the board, let's try to detect the one row for starters. So if board, and I will hard code it just like in this case to avoid creating a loop. So if this equals board 0, board 1, and can I do this thing in Zig, like do multiple equalities? I'll just print here, whatever. Thing like, let's say here, I will print, it doesn't matter. Oh, okay. Just to test if this equal will run. First cannot change, so I cannot change, so I have to use the AND operator. And if I'm not mistaken, it's like in Python, like AND the word, not the ampersand character. Let's see this one. And this will of course catch the underscores if they're equal, so I have to okay, this is now formatter. Yeah, okay, of course, because I put this, but I still have this bug that it will, a logical bug that it will detect if the underscores are equal. No, actually it doesn't. Okay, it doesn't print A at all. It doesn't detect it. Aha, it does. I'm blind. Okay. Aha, here, because I tested the first row only, and I actually put X there before I tested. That's why it doesn't see the 3 equals. But I have to ask anyways for the others, and for the sake of validity, I have to say that it's not equal to, so any of them, doesn't matter which. Let's use the first one, or let's use the last one, the closest one. This one not equal to underscore. And let's say here winner is, and then let's do interpolate here current player. So this is also a string, so it needs S. The winner is, let's do, and then current player, I believe I called it like that. Yeah. And let's do repeat this for other. So 0, 1, 1, 2. Then we have 0, 1, 2, 3, 4, 4, 5. And then let's say 5 not equal this one. And the third row will be 6, 7, 7, 8, and 8 not equal the underscore. So let's see if it will detect the row once it fills the first one. What does it say? This is again for mother. Current player. What is it, the current player? I forgot. It's symbols. Okay, as C. I forgot. Okay. It's a number under the hood. Did I run? No. Still missing something. Binary, so this is definitely S. Why here is it saying in? It doesn't say in which line in my code. They say just like under the hood. Which line? So current player. It is a character. So why this does not work? So let's try without this, just to see if the detection itself works, and then I will play with formatting. No, so it's somewhere else. Where? Ah, okay, because I deleted only one. Okay. Okay, turn 2 nothing, turn 3 nothing, turn 4 nothing. That's okay. So in 5, yeah, we see in the 5 that there is a winner. So that is correct. But for some reason, I'm not printing this the same way like here. Why? So let's undo the changes and just see what am I doing wrong. Okay, I changed only the last one. I'm crazy. So this one was 8. So here, see, a copy paste problem. I don't know how many times I did this to myself. Like, it's better not to copy paste than winner is X. Okay, this makes sense. And then let's do the \n. And I also want to break if there is a winner. Basically, then it's game over. And if afterwards there is turn number 9 and we don't have a winner, then it's a tie. Right, so that's another, like the last simple thing to do. But let's now try to detect the columns. So the columns should be and should be, I actually haven't tested. Let me first test if this is going to break now, and let's do the end part. So this is a function, right? So here I want to print the end. Let's just do game over. That sounds more like the end of the game, and this can be then empty. Yeah, and I forgot to do where I forgot the \n after. The winner is my mistake. I did it in the wrong place. I wanted to do it here. Here, of course, and here the same. So I'll copy paste one more time. Just let's test one more time. Yeah, okay, now it looks nicer. And now let's try to test the columns. So the columns should be 0, 1, 2, 3. Then 3, 4, 5, 6, right? 6. I can actually see here. They're aligned. So 6 and then 6 not equal this. Then 1, 4, 7. Okay. 1, 4, 4, 7, and 7 again. Then where am I? 2, 5, 8. So 2, 5, 5, 8, and 8 repeats. That's cool. And now let's change the moves. So let me just do kind of the opposite. So I will go down instead of right. So I will go first. This is 9, okay. This is okay. Then I'm not going to go 1. I'm going to go 3. That's down, right? So then this can be 1, but it will break anyways. Then 7, it's okay. Then not 2, but 6, I believe. And here it's 2, but it should detect winner already here. So let's try now. Yeah, it looks like it detects this one here. And let's do the diagonals, and that should be it for the winner. Yeah, sorry, Robert, I didn't see your message before. You can't you can just put the fixed text to the left format string. Okay. Yeah. Probably that's one of the reasons why it didn't work. I even forgot what I did in the last 10 minutes. I'm always focusing on the next thing. Give me just a second to see. 1, 2, 3, 4, 5, 6. Yeah, sometimes I have attention like a goldfish. So literally, I don't know what I said 5 minutes ago. Okay, now let's do the diagonals. So 0, 4, 8, I believe. So 0 and 4. 4 and 8. That's the top left to bottom right. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And then the remaining one is, let's say if we go top to bottom, so it's going to be 2 or 6. Okay. 2 or 6. 6. And now I have to make it diagonally. So let's do 4. What did I do first? 4, 0, 4, 8. So let's do 0, then here 4 instead of 8. And then, oh no, this is the, yeah, this is O. So I'll have to change a little bit. So 0. So this I will see what it will be. So it can be, let's say 1, doesn't matter. Then 4 here. Then this can be 2. Then 8 here. And basically afterwards it doesn't matter because it will be game over. Should be. But let's finish. So let's say now 3 here. Then what I'm missing? 6, 5, and 7, I guess, is the missing one. 0, 4, 8 should be the diagonal like this. And should end the game. Okay. Let's run, yeah. Let's see if this is going to detect the diagonal. So far, so good. Yeah, it does detect diagonal. And basically, if I don't have the winner is, then it's a tie if I reach the last. So I can ask technically here if the turn is 9 and I'm here, it's a tie. But if I strictly wanted to do this after, then I can set some flag and say tie equals to true, and then just let's do that. So I went too far. So let's say variable tie equals false at the beginning, and then here I set it to true. So tie equals true, and then no, actually I print the winner is before the game over. So then I don't need this, yeah, my mistake. So I don't even need the flag. I can simply just print if turn equals to 9 and I'm here, then I can just print it's a tie. So let's do this. Oh, yeah, only one thing I don't need. The winner is X. Yeah, I have to make it a tie. So now, this is not so easy. Okay, so let's say the first throw starts with 0, then I'll place 1, then here I play 3, then 4, then I have to do the opposite here. So let's say this is 4, 5, 6, I think. 6 and then 2, right? So then here what I had, these are different, so it doesn't matter what I have here. These are the same, so this part has to be O, so I have to play 7, I guess, here. So 7. Then, no, this will be O, so it doesn't matter. I can even play 6, yeah. So let's do 6, oops, here. 6, I will test it and I will see then. It's easier than to memorize all these. I made this, yeah. So yeah, I forgot there. Yeah, okay, so here to avoid this, I have to make this 7, for example, and then let's do this 6. And let's see then. Is it 7 or 6? Maybe I'm yeah, 6, not 7. So this is the one that I have to change. So this one has to be 7. Then when this one is 7, this one can be 6. Then let's see what are the remaining ones. 2, I believe. This can be 2. Then 5. Can that be O? Yes, it can. And then 8. Let's see. Yeah. Okay, nice. So I guess this is it. So it was a nice experience practicing things that I learned and that I forgot. So remembering things that I relearning basically the things that I forgot. So I'll try to do this even before then. So I not to spend 10 days again without something like this. So I will try to do maybe after the 5th, actually 15th in total day, something like this. Maybe I can redo the tic-tac-toe with functions and everything, and maybe to make it more interesting that I use pointers everywhere instead of just like using the integers and variables like this, that I actually use pointers, maybe slices to overcomplicate the tic-tac-toe. And also I will try to install Zig, maybe even tomorrow, on my local machine. And then once I have that, I will maybe play also with the user input. So that's the idea, that I overcomplicate the tic-tac-toe so that I use these more advanced features, the pointers and slices and so on, and functions, and then go from there. So let's say in about 5 days after day 15, I will try to do that. But today later, in let's say 1 hour or so, maybe a bit more than 1 hour, I will do the regular day 11 and continue with learning things. Okay, thanks guys for being here, and see you in the next stream or video. Bye bye. Yeah, usually I say bye bye here, but this time I forgot. Bye bye.